Today, we're really getting into it. We're cracking open what gets called the hard problem. Consciousness, the self, this whole idea of free will.
Yeah, the big ones.
Exactly. And our guide here is largely the framework from Zoltan El-Tori. The goal, and it's pretty ambitious, is to argue these aren't like complete mysteries forever,
Right.
but actually traceable physical processes, neurobiology happening, right inside your head.
And it's a dive we absolutely need to take. Because, frankly, the way things have been looked at historically, well, it's led to what you could call a dismal impasse in a lot of fields.
How so?
Well, you have prominent neuroscientists, even today, who kind of dismiss consciousness. They call it an epiphenomenon.
Like a side effect, a ghost in the machine, basically.
Precisely. A ghost with no real job, no causal role. We want to replace that whole fiction with the facts of how the brain actually functions.
I like that. Fiction to fact. So what's the core idea then? What's this mechanism that, sets us apart, that let us make that evolutionary jump?
Okay, so the core thesis, the big idea, is that the human brain develops something fundamentally new, an offline internal response mechanism.
Offline, meaning not directly reacting to the outside world.
Exactly. You can almost picture it as a sort of second brain, functioning internally. This is what allows for self-awareness and, crucially, something called functional autonomy.
Functional autonomy. Okay, so that's the key to this feeling of free will.
It's a lawful, deterministic mechanism that feels like free will. That's the crux of it.
Okay, let's start the story where things got stuck. Homo erectus, big brain, relatively speaking about 1,000 cc.
Yep, not insignificant.
But the sources describe this like incredible monotony, 1,000,000 years, basically making the same hand axe over and over. Why wasn't just having a bigger brain enough?
Because that brain was optimized for online processing. It was a fantastic reaction engine, super tuned to the immediate environment.
Responding instantly.
Responding instantly, efficiently. Brain size, as the main driver, had sort of hit its ceiling. The real breakthrough wasn't just more brain, it was a different brain. Qualitative, not quantitative.
A rewired brain. Okay, walk us through that. How did the rewiring happen? Where did it start?
It starts with biology, specifically a process called neoteny.
Neoteny. That's about retaining juvenile features, right?
Essentially, yes.
Yeah.
Developmental regression. Human infants started being born in a much less mature state, neurologically speaking, more neuroplastic.
So staying kind of like a baby brain-wise for longer made us more moldable.
Exactly. That extended plasticity, that window, allowed for some really critical, permanent structural changes. And here's the really fascinating bit.
Yeah.
The left frontal motor areas. Originally, these were all about manipulospatiality.
Okay, meaning.
Handling things.
Yeah.
Coordinated movements, manipulating objects in 3D space. Think throwing, shaping, building.
Right.
Those areas they got annexed, functionally repurposed.
Repurposed for what?
To become the motor arm for speech, what we now know as Broca's area.
Wait, so the ability to handle thoughts grew directly out of handling rocks.
In a fundamental way, yes. That structural modification, that rewiring,
Right.
is the bedrock of this offline mechanism. It lets the brain manage itself internally, using words as sort of conceptual handles.
That's a huge idea. Thought and language physically rooted in motor control. And the language that resulted. We need to be clear, this isn't like animal communication at all.
Oh, absolutely not. That's critical. Animal signals are online. They're hormonal, tied completely to the immediate context. A danger call only works if the danger's right there.
Right.
Human language, it's context independent. It generates internal offline outputs. It lets us simulate, test things in our heads without actually doing them. It's a cognitive self-bootstrapping tool.
Okay, so the motor arm is ready. The rewiring's happened. How did we actually build thought? How did we get from, I don't know, grunts to grammar? It was a two-stage process, wasn't it?
That's the idea. Stage 1, building the basic lexicon. Think Tarzan talk. Nouns and verbs.
How did that work? What were words attached to?
They were attached to percepts, the brain's stabilized image of the world. And that stability is thanks to something called the constancy mechanism.
Constancy mechanism.
Yeah, it's this amazing neural process. It compensates for all the, apparent changes in how things look, size, shape, lighting changing. So we see objects as fundamentally invariant, stable.
Can you give a quick example?
No. Think of a car driving away from you. On your retina, the image gets smaller and smaller, right?
Right.
But your brain applies constancy. You don't perceive the car itself shrinking into nothing. You perceive it as the same object, just moving farther away. That stable object perception, that was the anchor for our first words. Tree, run, fire. simple nouns and verbs linked to stable percepts.
Got it. But like you said, man-eat, fire-hot. That's not complex thought. Stage 1 gives us the building blocks. How did we get the nuance? Adjectives, adverbs, sentence structure.
That's stage 2. And it seems to have emerged epigenetically, meaning it arose from the use of the system
How?
through repeated frontal scanning. The brain, using these newly repurposed frontal areas, kept scanning those basic word percept pairs, apple and the image of an apple, run and the feeling of running.
Okay.
And in doing that scanning, it started to filter out to extract the embedded features, things like color, shape, texture, mood, relationships between things.
So the brain looks at apple plus the apple image enough times and eventually goes, hang on, red is a thing, round is a thing. I can pull those out and name them separately.
Precisely. Those extracted features became the secondary vocabulary. Adjectives like red, adverbs like quickly, function words like and or under. This constant interaction and refinement allowed syntax, the structure of language, to sort of crystallize.
Now that bumps up against some big ideas in linguistics. Chomsky's view that grammar, syntax is somehow innate, an instinct, this framework seems to say.
Nope, it says absolutely not. The source material is pretty clear here. The structure of language, the syntax, isn't some intrinsic property of the mind just waiting to pop out.
So where does it come from?
It's dictated by reality, by the spatiotemporal causal matrix of the real world.
Wow. Okay, unpack that. Reality dictates grammar.
Think about it. Language has to accurately reflect how the world works to be useful, right? The sequential nature of events, the causal links, who did what to whom, what happened before what.
Or else it's just gibberish.
Exactly. So the rules of grammar end up codifying the rules of reality. If your language structure constantly violates causality, it fails as a tool for understanding and communication.
That's a profound way to look at it. Okay, so language is the mechanism. It also seems to solve another big problem, focus. Sustained attention. Animals are constantly distracted, right? Chasing the next stimulus. How did we lock onto things?
Through something called attentional oscillation. And this mechanism is actually a direct consequence of how our brain is physically organized, that asymmetry we have.
Explain that. The asymmetry drives the oscillation.
Yeah. So picture looking at a cup again. The visual experience, the percept of the cup, is processed largely in your right hemisphere.
Okay.
But the word for it, CUP, is primarily handled in the left hemisphere. These two things are linked, but they're in different places.
Separate location.
Right. So, to manage this pair, the brain's attentional searchlights have to rapidly bounce back and forth between the word representation and the perceptual experience. A very fast oscillation.
So focus isn't one steady beam, it's this rapid switching, like juggling attention between the word and the thing.
Exactly like juggling. And here's the kicker. This oscillation is apparently under voluntary muscle control, like scanning.
You mean we actively do it?
Yes. This physical act of scanning, this oscillation, is what guarantees lasting focus, unlike the animal brain that gets pulled away easily.
Right.
And this process stretches out the time between getting sensory input and producing an output.
It creates a buffer zone.
Precisely. It creates the global workspace where we can run these internal simulations. The source material says this is where time can be suspended, freeing our decisions from the tyranny of immediate response.
Okay, if oscillation buys us time, creates this mental workspace, then who's in the workspace? How does this physical stuff give rise to that feeling of I, the sense of self, of being the author of our thoughts?
The I. That experiential core. It comes down to feedback, specifically proprioception.
Proprioception. That's the sense of your body's position?
Yes,
Yeah.
but here it's about the doing sensation of mental work. When you speak, even internally, when you think, it's still a motor process, however subtle. Your brain is doing work. And that neural work generates its own sensory feedback, a signal that says, essentially, activity is happening here, initiated by the system.
So the feeling I am thinking this or I decided that is literally the sensation of the brain's machinery running that thought or decision.
That's the core of it. Your internal situation report, what the source calls the endogram, it becomes layered. It's double-stranded. Yeah. You have the content, what you're thinking about, and layered with it, you have the cosalience.
Cosalience.
That's the term used for the sense of authorship, of agency. It arises directly from the proprioceptive feedback of the thinking or internal speech act. That feeling is the experiential self.
Okay, this leads us right into the deep end. Free will. If the self is this feedback loop, then what we feel as choice. The source material calls it an introspection illusion. That sounds, well, it sounds like we're just puppets, doesn't it? How can we not trust that feeling of choosing?
It's the million-dollar question, isn't it? But no, it doesn't make us puppets. It means our introspection, our internal view of how our mind works, is flawed. We feel like we're these little uncaused causes, what philosophers call an entelechy. But that feeling is misleading.
Why? What's the flaw?
It's timing. Classic experiments like Lebet's work back in the day show that consciousness kind of arrives late to the party. The brain activity that signals the start of an action, the readiness potential, kicks off about 300 to 350 milliseconds before we actually feel consciously aware of having decided to act.
So the decision is underway before I know about it.
Effectively, yes. We don't have access to those initial neural events that kick things off. We only become aware closer to the action itself. So it feels like the decision just sort of appeared out of nowhere, uncaused.
And we convince ourselves afterwards that we could have done differently just because our language system lets us imagine alternatives. We
Right.
can run the what-if scenario in our heads.
Exactly. We can mentally generate counterfactuals, but the actual choice was already determined by processes we weren't aware of. However, and this is absolutely crucial, this doesn't make us passive automatons,
Okay.
because the human brain achieves functional autonomy. This is the really clever bit. It's a deterministic selection mechanism, but one that makes us, the organism, a causal co-determinant of what happens next. It involves two operational domains.
Okay, domain one.
Domain one is the options generator. That's the cortex, the mind, using its offline language system. It generates a whole field of potential actions, mental options. This is where you internally debate, weigh pros and cons, imagine possibilities.
All the what-ifs we just talked about.
Right. A rich menu of choices generated internally.
And domain two.
Domain two is the selection mechanism. All those mental options generated by the cortex are presented, more or less simultaneously, to the brainstem and limbic system,
The older parts of the brain.
the much older parts. This is described as the neural home of biological value. It's the deep repository of everything that makes you you. Your genetics, your life experiences, your accumulated values, emotional weightings, your personality.
And this happens when?
During that critical window, maybe around 200 milliseconds or so,
Mhm.
before the action is finally triggered.
So the brainstem limbic system acts like a judge.
It performs a kind of super-fast, implicit Darwinian selection. It scans the options provided by the cortex and automatically, deterministically, selects the one that is most congruent, most aligned with the organism's total biological value system and personality.
Like a filter based on who you fundamentally are.
Exactly. Think of it as the cortex writing the ballot paper with lots of candidates. But the brainstem holds the deciding vote, and it always votes according to its deeply ingrained principles.
I see. So the cortex generates the possibilities, the brainstem makes the determined choice based on our entire history and biology, and the conscious mind, aware of the options it cooked up, but not aware of the brainstem selection process, just feels like, I chose that one.
That's the model, the stacking of the cards, where the highest level processing feeds options down to the deepest level for a value-based, determined selection. That's functional autonomy. It's not free in the spooky, uncaused sense, but it's autonomous because the decision comes entirely from within the organism's own value structure. We are causal agents because our internal state determines the outcome.
Okay, that's a complex but coherent picture. And you're saying this integrated model helps clear up some long-standing philosophical logjams.
It really does. It helps debunk at least 3 major diversions that have caused a lot of confusion.
Let's tackle them. First up, Chalmers' hard problem. Why do we have subjective experience, the feeling of what it's like, over and above just processing information?
Yeah, the hard problem. The framework basically argues it's a traceable misconstruction. Chalmers perhaps asked the question the wrong way. Awareness, consciousness, subjective experience, it's not some optional extra layered on top.
It's what then?
It's the indispensable display canvas. It's the integrated readout, the endogram that the brainstem needs to do its job, to evaluate the complex, nuanced data coming from the cortex and select the appropriate response.
Wait, but if it's just a display, why does it feel like something? Why isn't it just like data on a screen?
Because it's not just data. It's the functioning of an unbelievably complex, integrated, living system. It's the system experiencing its own operational state. If you remove that internal display, that integrated conscious field, the brainstem has no platform to weigh the options generated by the cortex. It can't perform functional autonomy.
So consciousness isn't a side effect, it's the necessary working platform for our kind of decision making.
Exactly. It's the highest functional level of the system doing its work.
Okay, diversion number 2, computer consciousness. Can AI, based on this model, ever truly be conscious?
The short answer here is no, because consciousness, in this view, requires something called thermodynamic depth. It requires the immense unbroken chain of information processing and cellular cohesion going back 3.8 billion years to the origin of life.
That whole biological history.
That whole biological informational edifice. A computer is an artifact. It lacks that history, that depth, that self-organizing living structure. Its performance, however impressive, is essentially an extension of the human brain's own capabilities. Like a telescope extends vision. It doesn't have the intrinsic self-generated being of a living system.
Got it. And the third diversion, qualia. The redness of red, the taste of coffee, the feeling of pain. These subjective qualities are often seen as the ultimate mystery, maybe even non-physical.
Right, qualia. This framework offers a pretty neat biological explanation. They aren't non-material mysteries, they're analog transforms of digital nerve impulses.
Analog transforms.
Think about it. Nerve signals are basically digital. On-off, firing or not firing, that's a huge amount of discrete, choppy data flooding the brain. The brain needs a way to make sense of it, to handle it efficiently.
So it converts the digital code into smooth analog experiences, like color or sound or taste.
Exactly. It translates the digital flood into a continuous, user-friendly internal language. It's a practical, biological solution for information management, probably used all over nature.
But what makes humans different regarding qualia?
What's unique about us is that our language mechanism, this offline system, allows us to generate these qualia internally. We can conjure up the redness of red, the taste of an imagined coffee, without the actual stimulus being there.
So because we can create them internally through thought, we mistakenly think the qualia themselves are somehow non-physical or separate from the brain process.
That seems to be the root of the confusion. It's a feature of our advanced internal simulation capability.
Oh, okay, let's try and pull all these threads together. What we've described is this intricate, interlocking system. Consciousness, mind, language, the self, even our functional autonomy. It all emerges from specific, traceable, physical, neurobiological changes that happen during our evolution.
It's one integrated system. And if you zoom out even further, think about the really big picture. Life itself emerged 3.8 billion years ago. And when it did, it fundamentally changed the rules. It introduced information-based causation into a purely physical, prebiotic world. It broke the simple deterministic chain. And you look at the universe itself. The constants, the physical laws, they seem incredibly fine-tuned for life to exist, what some have called a cosmic put-up job. It raises the possibility that life, and eventually mind, might not be just some random accident.
But maybe an inevitable outcome.
Perhaps an obligatory manifestation of matter under certain conditions. A kind of cosmic imperative for the universe to generate systems that can process information, generate knowledge, and understand.
Which leaves us with a pretty profound final thought for you, the listener. If life and consciousness weren't flukes, if they were in some sense destined to arise from the fabric of the cosmos, what does that imply about our role? What's the obligation of this conscious living system, arguably the highest expression of life we know in the grand scheme of things?
If we are indeed expressions of this self-organizing, information-driven universe, maybe our purpose, our function, is inherent in our nature. To use this incredible offline system, this functional autonomy, to study, to understand, and crucially, to wield our causal leverage responsibly within that unfolding cosmic story.